Welcome back. This is an Aleks training video on naming the shape of molecules with one central atom and no octet rule exceptions. All right, so if I have a water molecule, H2O, and they want to know what its shape is, the shapes are usually one or two words, and that's why this question's like this. What word or two-word phrase best describes the shape? So they're making you guess the shape of H2O. Before I can guess the shape, I need to draw its Lewis structure. So I'm going to find what is the central atom. My guess is that it's oxygen. Oxygen would be in the middle, and then you have the two hydrogens attached to the oxygen. So I'm going to draw it. I'll have oxygen here as O. Okay, and then I'm going to I don't know, draw a hydrogen to the side, hydrogen to the side. Okay, how many valence electrons are on oxygen? Oxygen's in group 6, so there's 6. Hydrogen's in group 1, so there would be 1 and another 1, so there's 8 total. So I have 4 pairs to play with. So I already have 2. The 2 bonds are 1, 2. So I need 2 more sets of pairs. Well, I need an octet around the oxygen, so I'm going to write there would be 1, 2, 3, 4, 5, 6, and here's 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is obeying the octet rule. Hydrogen is obeying the octet rule because it has 2. The other hydrogen has 2. Everything is fine. So this is no octet rule exceptions. Great. So I'm now going to look for how many groups of valence electrons do I have around the central atom. Okay, so let me just give you that. You're going to, number 1, you're going to draw Lewis structure. Number 2, okay, count valence electrons around central atom. Okay. All right, so far we want to say how many. We've got 1, 2, 3, 4. I've got 4. All right, so I'm going to go down to my pictures that I've given you again, and I'm looking for AB4. AB4. So I've got A is the central atom, and B is the ligands that are attached to it. In this case, I've got 2 hydrogens, but I also have 2 sets of lone pairs. Those are attaching to the central atom. Okay, I've got 2 sets of lone pairs and 2 bonds. So that's an AB4, so it's a tetrahedral. Problem is that I only have 2 things sticking out. The other 2 are going to be invisible because they're just electrons. There's not an actual atom attached to it. So look over here for a second, okay, to this part. This is a tetrahedral here where I have a central atom and 4 things attached, okay? What if 2 of those things that are attached are electron pairs? If so, you remove one of the corner atoms, okay? So you'll have still a tetrahedral, but one of the atoms is gone. Then you're going to remove a second corner atom, and now you have a shape that's called bent. And that's what you have here. You've got 2 sets of these 4 of the tetrahedral, the 4 corners of the tetrahedral. 2 of them are just electron pairs. They're lone pairs. So there isn't an atom there. So when you remove the atom, you're going to end up removing a corner, and this can't exist as straight. Okay, it has to exist as bent. All right, so we would name this one as bent. So you're going to draw the Lewis structures, count the valence electrons, and then from your knowledge of the shapes, what kind of shape goes with the number of ligands. So if there's 2 but it's not bent, then it's going to be linear. It'll be a one-word answer. If there are 3, okay, 3, and there's no lone pairs at all, then it's triangular planar. Okay. If it is 3 attachments plus a lone pair, you're going to have this triangular pyramidal. It's a pyramid, but it's triangular pyramidal. If you have 2 lone pairs on the central atom, you're going to have bent. If you have no lone pairs on the central atom, you'll have tetrahedral. And then here, these two guys are where you're actually breaking the octet rule. This triagonal, bipyramidal, and octahedral, you're breaking the octet rule here. All right? So your answer is, drum roll, bent. So you have a one-word answer to this. Thank you very much.